All right, welcome Algebra 1 students to another video. We are going to be covering Chapter 7, Section 2, and today we're going to be multiplying polynomials. So the last lesson we learned about polynomials, we learned how to add and subtract them by combining like terms, and today we're going to be multiplying polynomials instead. Now, as you can see kind of here on the title slide, it may look a little complicated, but once I teach you something called the FOIL method, it should be kind of easy for us to multiply polynomials together. But once we get to something like this on the right side, that's when we're going to have to do something a little bit different. And I'll kind of explain the process on how we do that. Now, before we get into that, we need to recall a few more things that we've learned in the past semester. So, and also from yesterday's lesson. So a few things we should remember before we start multiplying polynomials. I want you to recall the following. The first thing is the distributive property, right? We learned this back in like maybe middle school or even elementary school. But if you're multiplying something like this, you want to make sure that you're distributing this A to the B and the A to the C, right? So when you do that, that's how you end up with the AB plus the AC here. The other thing we should remember is the product property. This one says, remember, this was from last chapter. If you have A to the power B times A to the power C, remember that means we add those exponents together. And then lastly, we should remember the standard form for polynomials. This was from yesterday's lesson, right? We learned that for standard form for polynomials, we want to write from the biggest exponent to the smallest exponent. So that's what we want to do after we multiply these polynomials together. But before we do that, let's go ahead and start with some very easy examples to kind of get us going first, and then we'll get into the multiplying polynomials. So for example, if I asked you to multiply these two together, x times x squared, we should remember from last chapter that this, if I'm multiplying two bases, remember that means our exponents are added, right? So this would be the same as x to the power of 1 plus 2, which would give me x to the power of 3, right? But I want you to know this kind of just like without showing that work there, right? We should know just by itself, if we multiply those, we could kind of do it in our heads, and that's what I want us to kind of get used to, okay? So here's another one. The distributive property, we should also notice from chapter 1, right? I'm going to take that 2, distribute it to the 4x and to the negative 3. So if I do 2 times the 4x, this would give me 8x. And if I do 2 times the negative 3, that would give me negative 6, right? These are all really easy stuff that we should be remembering from before. Now, where it's going to be a little different is this last example here. Let's say we had this x times 3x plus 2. This is when we're kind of combining the last two examples that we just did, right? If I do x times 3x, keep in mind that in terms of the numbers, the 3 is still there, but now I have that x times x, right? X times 3x. And remember, for multiplying two x's together, which both have a power of 1, this would be x to the power of 2, right? Because you're going to be adding those exponents together, just like what this product property mentioned, right? So now what we should know from here is if I do x times 3x, this should give me 3x squared, right? Because the x times x gives me the x squared. The 3 just stays because there's no other number with it. And then when I do x times 2, this is going to give me 2x, right? So this is the one that might be a little bit different from what we've learned before. But now we're going to start multiplying multiple variables together, and that's going to give us these variables with exponents now. So just to give like one more practice example, if you're still struggling, let's say I gave you like x times, let's say like 2x minus 3. Let's change it up a bit. Let's say we also had a 3 here on the outside, right? If we did something like this, I'm going to take the 3x and multiply it to the 2x first. And then the numbers 3 times 2, that gives me the 6. And remember, x times x. Again, I want you to think about this in your head, but it's kind of like doing this in your head where they both have a power of 1, which would give you x to the power of 2, right? So this would give me 6x squared. And then if I do 3x times the negative 3, that's how I get minus 9x. Okay, so that's what we would get for like this practice example here. But I want you guys to try this out now on your own. So here's a few you try problems. Go ahead and try these out. And once you're done, pause the video first, and then once you're done, resume it, and then we'll check to see how we did together. All right, so the first one, x to the power of 2 times x to the power of 3. Remember, I want you to do this in your head. Like, it should be nice and quick now. I should know that this is x to the power of 5, but again, just in case if there's some of you still struggling, remember, this means we have to add those exponents together, which would give me x to the power of 5 for that first one. For the second one, we're going to be distributing, so I'm going to take the negative 2, multiply it to the 3x. That's going to give me negative 6x. And then I'm going to take the negative 2, multiply it to the negative 4. That's going to give me positive 8. So for the second one, we should get negative 6 plus 8. And lastly, if I take the 3x and multiply it to the 2x here, the 3 times the 2 gives me a 6. And then the x times the x, that should give me x squared. And then when I do the 3x times the positive 5, that should give me 15x. So that's what we should have for the third one. And I'm hoping that we got these as well. Okay. Now, these were kind of like to get us started with multiplying polynomials, because now we're going to see stuff like on the title side, right? Remember, we saw things like these, right? We're going to multiply multiple polynomials together. So that's what we're going to practice now. So multiplying polynomials. Now, when we want to multiply those polynomials, there's a certain like we were using the distributive property, but there's a special type of distributive property that's going to be called the FOIL method. So when we're multiplying polynomials together, we're going to use something called the FOIL method. So on this right side here, I'm just going to show you how to use that FOIL method. And on the next slide, we'll have some examples and you try practicing this FOIL method. Okay. So after you have this written down, this is the two polynomials we're going to multiply together, and we're going to use the FOIL method. Now, what does the FOIL stand for, right? Those letters each mean something. So I'll walk us through the process, okay? When we multiply this, we're going to end up with something, and this is what we do. We're going to start with the F, which stands for the first. In other words, I'm going to take the first term in each of those polynomials, right? So if I look at this polynomial and this polynomial, I want to see what's the first term in each of those. Well, the first term in this polynomial is this x, and then the first term in this polynomial is this x, right? So I'm going to multiply those together first. X times x, that's going to give me x squared, okay? So that's what the F stands for. I'm looking for the first term in each polynomial. The O stands for the outer. That means if I look at this whole polynomial as a whole, these two polynomials, I want to see what's on the outside of these two polynomials. If I look at the outside of this entire thing, the outsides are your x and your positive 2, right? So those are the two things I'm going to multiply together now. X times positive 2, that gives me 2x. What's next? That's going to be I, which stands for the inner. So now, again, looking at this whole thing, what's on like the inside of these two binomials? The inside part is going to be the positive one here and the x here, right? Those are like the insides of these two polynomials. So if I multiply these together, 1 times x, this just gives me x. And then the last letter L stands for the last. So what that means is look at each polynomial, right? So here's this polynomial, here's this polynomial. Look at the last term for each of those. So if I look at the last term for the first one, that's going to be this positive one here, right? And if I look at the last term for the second polynomial, that's going to be the positive 2 here. So if I just multiply those together, 1 times 2, that's going to give me 2. And that's how we use the FOIL method. Now, the other way to think about it, if the FOIL method sounds confusing, we're basically using the distributive property. So the other way to think about it is just start with one of the terms in the first polynomial and distribute that first. So x times x gives me the x squared, right? And if I do x times the 2, that gives me, that gives me the 2x right here, right? So you could think about it that way. So take the first term and then distribute that. And then you could take the second term and then distribute that one, right? 1 times x gives you the x here. And then 1 times 2 gives you the 2 here. So that's the other way to think about it. You could think about using the FOIL first, outer, inner, last. But once you get the hang of it, what my brain tends to do is I just look at the first term, I distribute that one, and then I look at the second term, and I distribute that one. That's usually how my brain thinks about FOIL once you've done this so many times, okay? Now, once you do the FOIL, notice here that this is kind of like yesterday's lesson. We just want to start combining like terms together. So if I look at this, the only things we could combine are the 2x and the x. So when I write that and combine those together, this would give me x squared plus 3x plus 2. And this would be our answer for multiplying these two polynomials together. Now, the last thing I want you to keep in mind here is always write your answers in standard form, right? That's what we mentioned in the last slide, or sort of the left side right here, right? Standard form for polynomials. Whenever we multiply these polynomials, we always want them to be written in standard form. So write answers in standard form. It's just a good habit to have, and it just keeps everything nice and organized. Okay, so just keep that in mind when we're multiplying these polynomials. So on the next slide, we'll do a few more examples to practice the FOIL method, and then we'll do some U-tries after that. Okay, so here's some more examples. Let's say we tried this one, x minus 3 times x minus 6. So again, using the FOIL method, I'm going to take the first terms and multiply them together. So that's going to be this x times this x, right? Which would give me x squared. And then I'm going to take the outer terms. So that's the x times the negative 6, which would give me negative 6x. Then I take the inside terms, which are the negative 3 and the x right here, which would give me negative 3x. And then lastly, we're going to take the last terms of each, which is negative 3 times the negative 6, which should give me positive 18. Right, that's the FOIL method. And again, if that one doesn't really make sense to you, you could always think about taking the first term and distribute that first, right? X times x, x times negative 6. That's how you get the x squared and the negative 6x. And then you could take the negative 3 here and then distribute that to the x and the negative 6 to get negative 3x and 18, right? That's the other way you could think about it. But once you do that, notice here I could combine these x's right here. So once I combine those, I'm going to end up with x squared minus 9x plus 18. So that's what we should have for the first one. Let's try another example. Let's say we had this. So now we got some coefficients in the mix. Same thing though, same process. We're going to use the FOIL method. I'm going to take the first, the 2x times the 3x. That gives me 6x squared. Then I'm going to do 2x times the negative 5. Those are the outers. That's going to give me negative 10x. After that, we're going to multiply the insides, the inners, which is positive 1 times 3x, which gives me positive 3x. And then we're going to multiply the last ones, which are 1 and negative 5. That gives me negative 5, right? So that's the FOIL method. And again, the other way, if I did the 2x times these first, I distribute the 2x first. That gives me these two. And then if I distribute the 1 after that, that's how I get these two. That's the other way you could think about it. But after you do that, we could combine the negative 10x and the 3x together. And this is going to give me 6x squared minus 7x minus 5. So that would be our answer for the second one. Now, one more example. This is when we might have some powers with our variables here. So if we had something like this, n plus 2 times n squared plus 3. Again, same process. Don't freak out about the exponent, right? But let's say we did the FOIL method. I'm going to take the n, multiply that to the n squared. Remember last slide we learned if you're multiplying two bases together, then you add those exponents together, right? So this should give me n to the power of 1 plus 2, which is n to the power of 3, right? So that's what we should remember using that product property for our exponents. So that's our first. Our outer is going to be n times 3, which gives me 3n. The inners are going to be the positive 2 and the n squared. That gives me 2n squared. And then when I multiply the last, which are 2 and 3, that gives me positive 6. Now, after I write this here, there's really nothing I could combine. There's no like terms. So this is when we just write it in standard form, right? Remember, biggest to smallest exponent. So when I rewrite it in standard form, it would be n to the power of 3 plus 2n squared plus 3n plus 6. And that's what we should have for this one. So I'm hoping these FOIL methods and the distribution is making sense here. So let's go ahead and practice this on the U-tries here. There's 3 more problems on the right. Go ahead and try these out. Pause the video. Once you're done, resume it, and then we'll check our answers to see how we did. Alrighty, so let's try the U-tries. I'm going to go through these really quickly. So the first is z times z, gives me z squared. Outers is z times positive 6, gives me positive 6z. The inners is going to be negative 2 times z, which gives me minus 2z. And then my lasts are going to be negative 2 and 6. So multiply those together, I get minus 12. And then the stuff I could combine here are the 6z and the negative 2z. So once I combine those, this would give me z squared plus 4z minus 12. So that's our first one. Hopefully we got that as well. Second one, I'm going to show the other way, the like distributing the first and second term, because some of us might like it that way. So I'm going to take the r, distribute that to the 2r and to the negative 1. So r times 2r gives me 2r squared. And I'm going to do r times negative 1 gives me negative r. And now I'm going to take the second term, the negative 5, and do that again, right? Negative 5 times 2r gives me negative 10r. And then negative 5 times negative 1 gives me positive 5. So when I combine the r's together, those are the only thing I could combine. This would give me 2r squared minus 11r plus 5. So that's what we should get for the second one. Last but not least, the third one. I'll let you guys decide which way you do it. I'm just going to go through this one quickly just to save us some time. So using either method, you should end up with c to the power of 3 plus 8c squared minus 3c squared minus 24c. And looking here, it looks like we could combine the c squareds together, the 8c squared and the negative 3c squared. So once we do that, we should end up with c to the power of 3 plus 5c squared minus 24c. So this one would be our answer for the third one. So those are our U-tries. Hopefully we got the same answers there as well. Now, the last thing we're going to cover is if we have a binomial and trinomial together. Now, this one is when I want you to think about distributing multiple times. So what I mean by that is, do you guys remember if I gave you something like this? The FOIL method worked great, right? But the FOIL method doesn't work well with the binomial and trinomial because you have, for example, you have something like this, right? And there, you can't really use the FOIL method for this one. So this is where that other method comes in handy, right? Remember here I told you, like, think about using the first term and then distributing that first, and then use the second term and then distribute that one afterwards, right? If you were more comfortable with this way, then this is really going to help you on this slide. But for those of you that were not used to this way, you got to get used to this way to help us with the binomial and trinomial method. So I'll kind of show us here on this example how we're going to do that, okay? So let's say we had something like this. We had this binomial times that trinomial. What we're going to do is take the first term, which is the x, and we're going to distribute that to everything in the trinomial, right? So I'm going to take this x, multiply to the x squared, which would give me x to the power of 3. Then I'm going to take that x, multiply it to the negative 3x, which is going to give me negative 3x squared. And I'm going to take that x again and multiply that to the negative 2, and that would give me negative 2x. Right, so it's exactly what we've been doing, the distributive property, but now you're just doing it to every single term that's in that trinomial. Now, after you did that with the x here, you're going to do the exact same thing with the 5 now. Right, so now I'm going to take the 5, multiply it to the x squared. That gives me 5x squared. Then I'm going to take the 5, multiply it to the negative 3x. That's going to give me negative 15x. And then take the 5, multiply it to the negative 2. That's going to give me negative 10. Right, so it's basically doing that distributive property I showed you on the last slides. But now we're just doing it with a binomial and trinomial. Now, once you do that, again, from here, you're just going to combine like terms. So I could see I can combine the negative 3x squared with the 5x squared, as well as the negative 2x with the negative 15x. So once I combine those, this should give me x to the power of 3. The x squared is negative 3x squared plus 5x squared gives me plus 2x squared. Negative 2x minus 15x gives me negative 17x. And then I have that minus 10n at the end there. So that's what we're going to have. And this is what our answer would be for our first example. Now let's try one more. Let's try this one. Let's say we had n minus 3 times n squared minus 2n plus 4. Again, we're going to use that distributive property for each of the terms. I'm going to start with this n here and distribute that to all 3 of these first. And then we'll take the negative 3 and do that afterwards, right? So let's start with the n. I'm going to multiply that to the n squared. This gives me n to the power of 3. Take the n, multiply to the negative 2n. That gives me negative 2n squared. And then take the n, multiply it to the 4. This will give me plus 4n. After that, now I'm going to take the negative 3 and do the same thing. Negative 3 times the n squared gives me negative 3n squared. Negative 3 times the negative 2n gives me positive 6n. And then negative 3 times the positive 4 gives me negative 12. After we do that, let's just combine like terms. So I can combine the negative 2n squared with the negative 3n squared, as well as the positive 4n with the positive 6n. So after combining those, this would give me n to the power of 3 minus 5n squared plus 10n. And then we got that minus 12 at the end there. So this is the polynomial we should end up with as our final answer. So hopefully we understood that. Again, same thing as the last line, but now we just have a trinomial in the mix. Let's do a few U-tries, then we'll write down the homework and we're done. Okay, so pause the video here. Once you're done, resume it and we'll see how we did. Alrighty, so the first U-try, I'm going to take this x here, distribute that to all 3 of these. Once we do that, x times x squared gives me x cubed. X times the positive 5x gives me plus 5x squared. And then the x times the 8 gives me plus 8x. Now I'm going to take the 1 and repeat that same process. 1 times x squared gives me x squared. 1 times the 5x gives me 5x. And then 1 times the 8 is going to give me 8. And then the stuff I could combine here are going to be my 5x squareds and the x squared, and then the 8x with the 5x, right? So when I combine those, this will give me x to the power of 3 plus 6x squared. And then the 8x plus 5x gives me 13x. And then we could bring the plus 8 down at the end. So this is what we should end up with for our first one. For the second one, same process. Going to take the d, multiply it to the 2d squared. Gives me 2d cubed. Take the d times negative d is negative d squared. And then d times the 7 gives me 7d. Then take the 6. I'm going to distribute that. This gives me plus 12d squared. And then 6 times negative d gives me negative 6d. And then 6 times 7 gives me the 42. So now when I combine these together, which are my 12d squareds and the negative d squared, the 7d and the negative 6d, this will now give me 2d cubed plus 11d squared, and then minus d, and then we got the plus 42 at the end. So hopefully we got this as well for our second U-try problem here. But yeah, that's basically it. That's how we're going to be multiplying the binomials and trinomials, basically the polynomials all together. Again, I know in the last slides I showed you the FOIL method here, right? The FOIL method is great, but again, when you start using the FOIL method a lot, I just want you to think about it kind of like these last problems here. If I gave you like A plus B times C plus D, instead of thinking like first, outer, inner, last, I want you to get into the habit of thinking like, oh, I'm going to take the A first and multiply it to the C. That's my first. And then the A times the D, that's my outer. And then take the B times the C, which is your inner, and B times the D, which is your last, right? I want you to think about it this way because it really helps us with these problems here, right? All of these binomial and trinomial problems, because you can't really use the FOIL method for these because we got that extra term for our trinomials in the middle. So I want you to get into the habit of think about it this way because it really helps you with these last few problems here. But with that said, let's write down the homework problems, which are these. I want you to use the FOIL method and the other method I taught you, right? That's the distributive method, right? You're thinking of like the first term distributing that and then the second term distributing that. So I want you to use those methods for these problems here. 35 to 40, these are the ones with the trinomials. So if you feel like you were struggling with those, I would encourage you to focus on these problems here, okay? But that's about it. So thank you for watching the video. Hope you all enjoy the rest of your day, and I will see you all later.